attacking reagent. In this, two types of attacking reagent will be there. One is electrophile, another is called nucleophile. So it is called electrophile and it is called nucleophile. Okay, so electrophile are electron rich or electron deficient. Electrophile are electron deficient, whereas nucleophile are electron rich or electron deficient. Nucleophile are electron rich. Now first of all we will see the different types of electrophilic reagents. Okay, then we will move to the nucleophile. Okay, so first we will see the electrophiles. Okay, so electrophile. From next time I will not write electrophile like this, I will directly write this. Okay, so electrophiles again are of two types. What are they? Positively charged electrophile and neutral electrophile. First of all, what is electrophile? Electrophile or electrophilic reagents are those reagents in which, first of all, let's break this name. So electro means electron, electro means electron, and phile means loving. Electro means electron and phile means loving or philic. Electrophilic reagent will be there, na? So the reagent which attacks on the negative part of the molecule or loves electron are called electrophilic attacking reagent, or they are called electrophiles. For example, this is an electrophile. Take this electrophile as Na plus and take another chlorine minus nearby. What will happen? This Na plus will attack on that Cl minus. Why? Because it loves electron. That is why it is called electrophile, and it will always attack on the negatively charged species. It will always attack on the negatively charged species. Okay, so the reagent which attacks on the negative part of the molecule or negatively charged species or loves electron are called electrophile or electrophilic reagents. They are normally positively charged or they may be neutral. Now we will see the different types of positively charged electrophile and neutral electrophile. Okay, one is positively charged and another one is neutral. Positively charged electrophile means simply we know that they are electron deficient, so they need electron. But what is about neutral electrophiles? Neutral means they are neutral, they have sufficient amount of electrons. Then why they are attacking on the negatively charged species? Let's see that. Okay, so example of positively charged electrophile are, what are the example of positively charged electrophile? You can say H plus, you can say SO3H plus, so H plus, SO3H plus, nitric oxide, nitrous oxide, nitric oxide, nitrous oxide, halogen, positively charged halogen. After that you can also say alkyl group. Alkyl group also electron deficient. Then carboxyl group, RC double bond O, positively charged. Why it is positively charged? Because oxygen is more electronegative, so it will try to take the electron. Okay, is it visible? Okay, after that you will see that C6H5 along with this N species. Okay, this will be electron deficient. Okay, so what I want to tell you that these all are positively charged species: hydrogen, sulfonium, nitric oxide, nitrous oxide, halogen, alkyl group, carboxyl group, and benzyl group. These all are positively charged species. Okay, but remember, when the neutral species comes, it will have electron deficient on the central atom. For example, take A, along with this take B, B, B. So this B will be more electronegative. All these three B will be more electronegative, and they will try to attract. Already I told you what is electronegativity. It is the tendency of an atom to attract the electron. So all these three B will have more tendency to attract the electron from A. From A. A is the central atom. So when all the three B will try to attract the electron from A, what will happen? The A will become electron deficient because the electron density on A will decrease. When the electron density on A will decrease, it will act as an electrophile. Yes or no? So now write the different example of neutral electrophile. What are the different example of neutral electrophile? Neutral electrophile. Example is BF3, AlCl3, BF3. See, fluorine. Fluorine is highest electronegative atom in the whole periodic table. So it is more electronegative. More electronegative means it has more tendency to attract the electron. BF3, then SO3, then AlCl3, then AlCl3, then write ZnCl2. After ZnCl2, you can write FeCl3. After FeCl3, you can write SnCl2. After SnCl2, you can write CO2. After CO2, you can write SnCl4. These all are neutral electrophilic species or neutral electrophilic attacking reagents. Okay. After that, you have to remember one thing, that these neutral species or neutral electrophile species has electron deficient atom at the center. So for example, if you take the structure of BF3, the structure will be like this: boron, fluorine, fluorine, fluorine. So these fluorine are more electronegative. They will try to attract the electron from boron. What will happen? Boron will become electron deficient. They will become electron rich, partial electron rich, and boron will become partial electron deficient. When it will become partial electron deficient, it will act as an electrophilic species. Okay, so this is most important. So what are the most important point I have mentioned here? The most important point that I have mentioned, first of all, central atom is electron deficient. Central atom is electron deficient. Next, point 2 is that these free radicals such as carbene and nitrogen. Okay, I'll tell another things. This neutral electrophilic reagent, these will also act as Lewis acid. So you can also remember like this: all Lewis acids are also neutral electrophiles. Okay. After that, you will see carbenes, nitrines. So carbenes, C double bond, C single bond double dot, nitrines and double dot like this. Okay, we will see the structure after a few minutes. First of all, let's understand the examples only. After knowing that example, then we will go further proceed to carbene, nitrine structure and all these things. So this carbene, just remember carbene and nitrine, they will also act as electrophile. Okay, carbene and nitrine will also act as electrophile. Now electrophile is completed. Let's move towards nucleophile. So in the same way, electrophile, how many types of electrophile are there? Two types of electrophile. What are they? Positively charged electrophile and neutral. In the same way, nucleophile will be of two types. Nucleophile, two types. What are they? Negatively charged nucleophile and neutral nucleophile. Negatively charged and neutral. One is negative, number two is neutral. So negatively charged means already they all are electron rich. They all are electron rich. And neutral means it doesn't have any extra charge on it, but what will happen? They will act as Lewis acid. And what is the Lewis acid? And what is the character or property of Lewis acid? They will donate or take the electron. They will donate. so they will try to donate the electrons. That's why they also act as nucleophile. In another word, in another way, I will tell you that nucleophile also, if we break the name, then nucleo means nucleus, phile means loving. So nucleus loving. Now nucleus, in an atom, you will see a nucleus will be there surrounding some shell in which electron will be filled. So this nucleus is positively charged or negatively charged? This nucleus is positively charged. Positively charged or neutral? It is positively charged. What are present in the nucleus? In the nucleus, you will find proton and neutron. This neutron is neutral, but this proton is positively charged. Okay, this proton is positively charged. So neutral proton is positively charged. What does it mean? It means these reagents which are nucleophile, these will love positively charged species. Yes or no? Nucleophile will love to attack on the positively charged species. Why they love positively charged? Because they already have more electrons, and they will try to donate the electrons to the electron deficient species. Okay, so nucleophile are of two types. Now you have to remember that nucleophiles may be negatively charged, and nucleophile may be negatively charged ion possesses a lone pair of electron. Okay, for example, take oxygen along with R, or cyanide, or you can take NH2 also. Yes, they all will have negative charge. They will have negative charge. Along with that, oxygen has lone pair. Here nitrogen has lone pair. Here also nitrogen has lone pair. Yes or no? So they will have either lone pair or they will have extra charge, extra electrons loaded on them. Okay, that's why negatively charged nucleophiles. All Lewis base also act as nucleophile. Okay, tell me some more examples of charged nucleophiles. Negatively charged nucleophile: H. You can also take OH. You can also take OH. You can also take CN, cyanide, already taken. You can also take halogen is also negatively charged because it has more electronegativity. Halogen is also electrophile. It can also act as nucleophile. Then RC, double bond O, single bond O, negative charge. It can also act as negatively charged. Yes, NH2 is also there. Then SH, in this sulfur will have negative charge. So they all are charged species. They all are which type of charged species? They all are negatively charged species. Okay, so you have to remember that. After that, all the Lewis base also act as Lewis base will also act as nucleophile. In this Lewis base, you will see different types of see, for example, H2O. In this, oxygen has lone pair. After that, alcohol, ROH. Again, oxygen has lone pair. After that, ROR, that is ether. Oxygen has lone pair. After that, NH3, nitrogen has lone pair. After that, NH3, nitrogen has lone pair. Then you can take unsaturated hydrocarbons. Unsaturated hydrocarbon like C double bond C. Yes or no? So CH2 double bond CH2 or CH triple bond CH. They all are neutral nucleophiles, because this triple bond is also highly electronegative. Double bond is also more electronegative than single bond. Then what is saturated and what is unsaturated hydrocarbon? Saturated hydrocarbon are those hydrocarbons. Saturated hydrocarbons are those hydrocarbons in which only single bond is present. Only single bond is present. Whereas unsaturated hydrocarbon are those hydrocarbon in which double bond or triple bond will be present. Double bond or triple bond will be present. So double bond, triple bond having hydrocarbons are called unsaturated hydrocarbon, and saturated means single bonded hydrocarbon. Okay. Next we will proceed further. These all are about attacking reagents. So first we learn about nucleophile, sorry, electrophile. Then we know about nucleophile. Nucleophile are how many types? Two types. What are they? Negatively charged nucleophile and neutral nucleophile. And electrophile are how many types? Two types. What are they? Positively charged electrophile and neutral electrophile. So neutral